Alright, so today's objective is to find the limit by the rationalizing technique. Okay? The two words that you need to remember from pre-calc is to rationalize and to conjugate. So do you remember what it is when did you come across the rationalizing part? Do you remember? In your pre-calc. Yes, you can. Exactly. So when you have this, I'm just showing you, I'm trying to bring it back to your memory. So say you have something like 2 over square root of 3. You remember square root of 3 is irrational. We cannot have an irrational number in the denominator. So you multiply the square root of 3. So what happens over here? It gets you. So you see, from an irrational denominator, you've got into a rational. Remember this?
Yeah.
So that is if you have one denominator. Now, so rationalize is nothing but the process by which a fraction is rewritten so that your denominator is only rational. Okay? Now another example that I want to bring to your attention, and you have done this before last year. It is say 1 over square root of 3 minus 1. Sorry? Sorry. So while she's writing, do you remember what we did with this? Right? Square root of 3 minus 1? Remember, see, you just had only that, but when you have the two terms, the whole thing, but what about the sign of it?
That's right.
You have to switch the sign, exactly. Remember, we did conjugate, that's what it is. To change the sign of the middle two terms. So, you remember we multiplied and divided it by this? You remember? Huh?
It was other way around.
Yes. So whatever, if your denominator, so this is my first example, this is the second one, this is just your prerequisite from pre-calc, not limits yet. Okay. So what happens over here, do you remember? Square root of 3 plus 1 divided by what, all of them together, yeah, what is it? 3? Then? 3 minus 1. Remember it was a minus b times a plus 3. This is of the form, see, you multiplied this whole thing, right? Remember it is a plus b times a minus b, so you square it. So you get square this one. So a squared. When you square a square root, it becomes 3, say minus 1. Basically, the square root is removed. It cancels out because remember square root of 3 times square root of 3 is going to be square root of 9. Yeah, so it doesn't, this one?
No, it's not good.
The top remains there.
No, you can just against it.
I don't care, no, I'm just showing you that.
No, I think like it's good, but you guys have yourself on the top of this food.
It remains there.
Wait, what is
You cannot cancel. Look, why? It's because it is a plus 1, exactly. See, square root of 3 plus 1 divided by the denominator becomes 3 minus 1, which is 2. Are you following? See, what did I start? I started with this, right? So, since you have a irrational denominator, you multiply and divide by its conjugate. So do you guys understand until this part? Is this coming back to you? Now, from here to here, you multiply the numerator. So it just remains as such. Now the denominator, you have the same thing. So you do a minus b times a plus b, which is a squared. The square root of 3 squared. So when you do this, it becomes positive 3. Remember that? And then minus b squared. It is of the form. See, it's like a minus b times a plus b, which becomes a squared. So square root of square root is just that number. The square root goes away. Minus b squared, which will just be 1 squared is 1. Is it coming back?
Yeah.
So I'm sorry.
So wouldn't it be like, we're saying it like the square roots?
Ah.
All of them.
Okay. Can you try one before we move on to the other one? So let's try 2 divided by square root of 2 minus 1. Number 8. So page 64, example 8. Okay? So this is a limit problem where you have limit x approaching 0. Alright? So this is the limit. We need to calculate what the limit is. Alright? Now, try. So before we go on to solving this problem, I'm showing you the longer way to solve this problem. There is a shortcut also. But unless you know the long way, you will not be able to get to the shortcut. Okay? So let's first understand the long way. So can we start to apply the limit directly? What happens when we apply the limit? Yes, Sophia?
We get the square root of 1 minus 1 over
Okay, so